This is a sphere, and this is the formula to compute for the volume of this sphere. Do you know how to derive this formula? In this lesson, I'm going to show you how to derive this formula V equals 4 over 3 pi r cubed. Let's begin by situating our sphere in this three-dimensional space in such a way that its center is at the point of origin. And then let's turn our sphere a little bit. We are looking at the sphere at its front view. Then let's slice our sphere into very thin discs so that from our vantage point at the front view, the discs may look like rectangles shown in this figure. Let's focus on one of those discs. Looking at a different perspective, our disc may look like this. The height of our discs is denoted as y, and the width of our discs is denoted as delta x. And then let's zoom out this disc. So we have here, the radius is y, and the thickness is delta x. We can also position our disc sideways. Still, the radius is denoted as y, and the thickness of our disc is delta x. So what is the volume of this disc? Our disc is a cylinder. The base is circular, and the height is denoted by this thickness, which is delta x. And we know that the formula to compute for the volume of a cylinder is the area of the base times the height. In our case, our base is a circle, so the area of the circle is pi radius squared, where our r is the radius of the disc, denoted by r subscript d. And our height is this delta x, or the thickness of our cylinder. But in our notation, the radius of the discs is denoted as y, and the height of our cylinder is equivalent to our delta x, which is the thickness of the cylinder or the height of the cylinder. Now let's go back to our sphere that we sliced at the beginning. Let's begin with this red rectangle that is perpendicular to the x-axis. And then let's rotate this rectangle 360 degrees around the x-axis in order to form this disc. What is the volume of the disc resulting from this rotation? A while ago, we already said that the volume of this disc is V equals pi y squared delta x. So knowing that the volume of the disc is pi y squared delta x, then to find out the volume of this entire sphere, what we need to do is slice this sphere into infinite number of discs like this and sum up all the volume of those thin discs. And that idea of summing up all these volumes of this thin disc is now computed using calculus technique, which we call as integration. So if we want to find out the volume of this sphere, first is we are going to slice this sphere into tiny discs from 0 up to this point on the circle, which has this distance of r, and getting the volume of each of those discs from 0 to r. Since the volume of one disc is pi y squared dx, and we want to sum up the volume of these discs from this point x equals 0 to x equals r, then we can now sum up all these volumes with changing height, because the height would depend on the value of the function. And summing those up would now be this elongated s, which is our symbol for integration, and we are going to perform the summing up of these volumes from x equals 0, which is now this number, up to x equals r. But the volume that we can get would only be the volume of all the slices in this right half of our sphere. We need to find also the volume at this left side of our sphere. And since our sphere is symmetric with respect to the y-axis, then if we know the volume at the right side, what we can do is just multiply the result by 2, which is now this 2, in order to get the volume of the entire sphere. So that is our plan. But look at our formula. Our formula is in terms of y. When we compute for the volume of the sphere, usually what is given is only the radius of the sphere. So what we want to do is express this variable y in terms of r. And how can we do that? Look at this right triangle that we formed. We have a hypotenuse of r, the length of one leg is x, and the length of the other leg is y. Using now the Pythagorean theorem, we have the formula x squared plus y squared equals r squared. And so, we can now express y squared in terms of r squared and x squared this way. Y squared equals r squared minus x squared. And since y squared is equal to r squared minus x squared, then we can now replace this y squared with r squared minus x squared. All the rest are just copied. We copied the 2, we copied the integral from 0 to r, we copied the pi, we copied dx, and change y squared with r squared minus x squared, and we replace this delta x with the differential dx. The idea behind this dx is that we slice our sphere into infinitely thin disks in such a way that the width denoted by dx is infinitely thin. So the width of our disk now is very, very thin, infinitely thin. So this is now the part that we are going to compute in order to derive the formula of our sphere. So let's simplify now this integral. Notice that this pi is a constant, so we can pull that outside the integrand. And so we now have this next line. Next, notice that r is a constant. So, the antiderivative of r squared dx is r squared x, because r is a constant. The antiderivative of a constant is a constant times the variable of integration. Then the antiderivative of x squared dx is x cubed over 3. In both cases, we did not write the plus c anymore because when we evaluate this expression, the c will just be cancelled out. So let's simplify now this last line. Evaluating at x equals r, we copy the 2 pi, we copy the r squared, we replace x by r to get r squared times r, copy the minus, we replace x by r again to get r to the third over 3, minus, then evaluate the same expression at x equals 0. And so we replace this x by 0, we replace this x by 0. This right part is equivalent to 0, so what would be left is this first term. Then simplifying this, copy 2 pi, r cubed minus r cubed over 3 is 2r cubed over 3. And simplifying further, 2 times 2 is 4, copy the pi, copy the r cubed, and copy the denominator 3. And so, we now arrive at this formula, which is also equivalent to 4 over 3 times pi r cubed. And so, as long as we know the radius of the sphere, we'll be able to compute its volume using the formula volume equals 4 over 3 times pi r cubed. This is how we derive this formula. So thank you very much, and we hope to see you again in our next video.